Hello everyone and welcome to class. So we'll be starting with our first week for the first term scheme of work for SS1, and our topic is indices. I'm sure you must have seen the scheme of work. Our topic is indices. So we'll be kickstarting. Indices actually refers to what we call our power or our exponential. When you see 2 raised to power 3, 5 raised to power 2, I'm sure you must have been doing that from your primary school days. So you have this 3 raised to power 4, and this number down here, 3 here, is known as the base number, while 4 is known as the index or power. The index or power. Now how does this work? Now 3 raised to power 4 is just simply saying multiply 3 by itself 4 times. So 3 raised to power 4 will be equals to 3 times 3 times 3 times 3. Now 3 raised to power 4 will be equals to 3 times 3 times 3 times 3. And index is the singular form, while indices is the plural form. So when we speak of it in its plural form, we always use the word indices. And we have our laws of indices clearly stated here. I'll be releasing a material that shows the proving of these laws, but we will not be spending time in proving the laws in this video. This is to make it quick, and so that we can go straight to solving questions related to indices, and so that we can make much progress with short time. We have our laws of indices here. Now for the multiplication and division of indices, always take note that the numbers must have the same base number. It must have the same base number for both of them, and then you can now safely add up or subtract their powers when due using these laws. Now anything raised to power 0 is equals to 1. 100 raised to power 0 is 1. 1 million raised to power 0 is 1. And then when you have a negative power, you find the reciprocal of that same value. But by the time you find the reciprocal, you just have to remove the what? The negative power here. Remove the negative power here. So x raised to power minus a will be equals to 1 over x raised to power a. And then you have powers that are separated by brackets like this. So you have a value with power in a bracket, and then all raised to power another value with another power. What do? You just do what? Simply multiply the what? The powers. You simply multiply the powers and you get your answer. Moving to our fractional indices, once it is raised to power 1 over a particular value, what you have as a particular value in the denominator, in your index, will now serve as the root for this particular value. So if it is raised to power 2, you find the square root. If it is raised to power 3, you find the cube root. If it is raised to power 4, you find the fourth root. Now if it is now raised to power a over b, where a is a number greater than 1 and b is also a number greater than 1, what do? This is what we do. We find this value raised to the power of a, and then find the root. So whatever end up being the denominator, not the numerator now, the denominator here, still will remain the root here also. This only occurs, that all these laws are only valid where x is not equal to 0. Where x is not equal to 0 in all cases. Imagine having 0 raised to power 0 here. Now before we proceed, I would love to recommend something that would be of help to you if you are having problems with indices, because most times what people will have problem with will be the powers. Will be how to spot the cube roots, the fourth roots of certain numbers. What you do is you can create a chart. You can get a cardboard paper and stick somewhere up in your room, or keep it somewhere around you, or even at the back of your mathematics note, or a note that you can specially keep for these purposes. You can create a chart, and then you can start with 2. When you start with 2, you create your chart like this. can probably take it to 8. So raised to power 1, raised to power 2, raised to power 3, raised to power 4, raised to power 5, raised to power 6, raised to power 7, raised to power 8, raised to power 9, raised to power 10. I think 10 should be fair enough. So what do we do now? We start with 2. Of course, you know anything raised to power 0 is equals to what? 1. So there's no need for raised to power 0. Are you getting me? And anything raised to power 1 is actually itself. So 10 raised to power 1 is 10. 20 raised to power 1 is what? 20. So we start with 2, and then you put 2 raised to power 2 will now give us what? 4. 2 raised to power 3 will give us what? 8. 2 raised to power 4 will give us what? 16. 2 raised to power 5 is what? 32. 2 raised to power 6 is what? 64. 2 raised to power 7 is what? 128. And so on and so forth. You cross it. You go to 3. 3 raised to power 2 is 9. 3 raised to power 3 is 27. 3 raised to power what? 4 now is what? 81. And then you keep on going and you keep on going. You can make this chart from 3 to 4 to 5 to 6 to 7, probably down to 10. And with this chart, you will find out that finding the square roots, the cube roots, the fourth root, fifth root, sixth root of certain numbers will not be as hard as it seems again. We'll be quickly solving these simple indices questions, and we'll start with the first one. 3m raised to power 4, all in brackets, raised to power 2. Now I need you to take note that this power of 4 does not affect this 3 here. This power of 4 is only for m. Now this 3 will be affected by this power, and this m raised to power 4 will also be affected by what? By this power. And so when we multiply, or when we expand the bracket, we have 3 raised to power 2 times m raised to power what? 4 times 2. Now before I proceed on this, to enjoy this class, what you do is, the laws of indices I've written out before, write them out on a sheet of paper. Write them out on a sheet of paper and compare them with this question or any other question or any questions you will be solving. Write out your laws of indices on a sheet of paper and put it beside you whenever you are solving your questions on indices. Now this would help you to easily discern or pick the right law to apply for every step in your solutions or for every question you are solving. Okay, now you have this. You will now have 3 raised to power 2 times m raised to power 8, which will now be 9m raised to power 8. Now somebody will ask me, how do we get 2 here? Now, for every ordinary number like this that does not have an index, automatically it has an index of 1. Every ordinary number you see, for example 9, like this, 9 is always raised to power invisible what? 1, except stated otherwise. That means except it is officially given what? An index in the question you are what? Solving. Okay, let's go to the second question. We have 5x squared times 4x raised to power 0 times 2x raised to power minus 6. Now, first off, when you see anything raised to power 0 here, what do? It's equals to what? 1, according to our laws of indices. Remember I told you, bring the laws, write it out on a piece of paper, not the one in your notes, on a piece of paper, and put the piece of paper beside you as you solve your questions. Now you have 5x squared times x raised to power 0 is what? 1 times 4 would give us 4 times 2 raised to power what? X 2x raised to power minus 6. Now we proceed further, multiply all the whole numbers together. Now because we are multiplying them, it's possible to do that. If it was addition, it will not be what? Possible. So when we multiply them, you have what? 5 times 4 is what? 20 times 2 is what? 40. Now you have 40. 40 what? 40x squared. 40 times x squared times what? X raised power minus 6. Now because 5x squared means 5 times x squared. And 2x raised power minus 6 is the same thing as what? 2 times x raised power minus 6. I'm sure you know this by now. This will be equals to what? 40. Now apply the laws of indices. You have what? X raised power 2 plus minus 6. Why? Because it's what? Times between them. Do you remember the first law of indices? Yes. And we cannot remove this negative power that is here. Doing that, you will now continue and get what? 40 times what? X raised power what? Plus times minus will now give us what? Minus. So you have 2 minus 6. Which will give us what? 40x. 2 minus 2 will give us what? Minus 4. This is our answer for this question. We go to the last question. A raised power what? Minus 9 divided by b raised power 0. This is very simple. Remember that what? Anything raised power 0 is equal to what? 1. So this is equal to what now? A raised power minus 9 divided by 1. Anything multiplied by 1 gives us the same value. Anything divided by 1 obviously also gives us the same value. So you get what? A raised power minus 9. Or another way of writing it is what? 1 over a raised to power 9. Check your laws of indices. Now we'll be solving these equations on indices. These equations on indices. Now this is the trick or the simple thing to note behind questions on indices. Most of the times you'll be having numbers that can actually be transformed to numbers with the same base but they might be of different powers. For example, what am I saying? This 5 here now is the base number here. Now this 125 that we're looking at here can be represented as having a base number of 5 with a power. So using your chart now, 5 raised power what will be 125? You will discover that 5 raised power 3 is 125. So you can now easily change this 125 here to what? 5 raised power 3. And this makes our work easy. What do? Are you following now? Then we bring what is up here down. Then you have what? X is equals to what? 3. That's it. It's that simple. Now, looking at the second question, also very easy. Is equals to 64. Like I said, the same base number now. This one also has a base number of 4. Now, you can actually represent 64 with 4 raised to power something. All you have to do is what? Check your chart. Make sure you have created your chart before you've come this far. You can pause the video before you get to this part. Create your chart so that we can what? We can make learning easy for ourselves. Okay. 64, if you check your chart very well and you've made your chart very well, you can use your calculator actually to make your chart. You will discover that 64 is equal to what? 4 raised to power 3. So why don't you substitute this? We will now have what? 4 raised to power what? C minus 1 is equal to 4 raised to power 3. What do? That's simple. What is up here? We bring it down. We now have C minus 1, is equals to 3. Now, collect like terms, you have what? C is equals to what? 3 plus 1. C is equals to 4. Very simple. We'll go to the third question. N raised power minus 2 over 3. Like I said, you have a chart on one side. For equations on indices like this, you have your chart on one side, then you also have your law of indices on the other side. Now, is equals to 9. Now, this is actually simple. Don't look at it as something hard. What we just need to do is now what? Take away the fractional index make it more of a normal index so that we can now solve it easily. Now what do we do? How do we remove this fractional index? Now whatever is the base value here, whatever is the denominator here, you will raise everything to that power. So for example, here now we have the denominator of what? 3. So raise all of them, all terms to the power of what? 3. We raise all terms to the power of 3. We now have what? N raised power minus 2 over 3 raised to power 3 is equals to what? 9 raised power what? 3. Are you following me now? Equals to 9 raised power 3. Now, being fraction, now also remember that what? We have our lovely that say that what? When you have something like this, you multiply both. Abi? Now if you multiply this will actually divide this. And you have what? N raised power what? Minus 2 is equals to 729. Are you following me? 729. How do we now remove this negative power? Just follow. You have 1 over n raised power 2 is equals to 729. This is another law of indices we are applying here. We cross multiply. We have 729 n squared is equals to 1. Divide both sides by 729. Then you have n squared is equals to what? 1 over 729. And then you find the square root of both sides, bar. And your n will now be what? 1 over 27. Your n will be 1 over 27. So we have been able to successfully solve 3 equations on indices. So we've come to the end of this class. Now to facilitate our learning, I'll be creating a Telegram group so that we can always bring out our questions so we can solve them together. And I'll also be releasing the questions for every class on this Telegram group. You won't be getting them on YouTube. You'll be getting them on the Telegram group. So you can join us on the Telegram group. All you have to do is what? Type KLS on the Telegram and you will see our logo showing up. You can become a member of that group or that channel and we can make progress together. Do have a nice day.